All right, moving on to the last part of this particular review, which is unbalanced forces. We got this inclined plane problem. What I want to do is I want to set up the equations here. Be really careful because things work just a little bit differently. So we're going to have this, and because it wants to slide down, friction is going to oppose that. And, you know, this is so important that I'm actually going to do this problem on a separate page. So inclined plane. Just to be clear on what this free body diagram looks like. First, the free body diagram, I'm going to draw the normal force like this, the weight pointing downwards, and the friction force like this. And I'm going to split the weight into two components. The first is going to be the W sine of 90, W cosine of 90 minus theta, because x is always cosine, and W sine of 90 minus theta, because sine is always in the y direction. Now, they say, what's the coefficient of friction between the block and the plane? So let's be clear. Theta is 17 degrees, and m is, let me just get that right, 20 kilograms. So what we need is, we need to get friction equals mu times the normal force. Now, what's happening here? Sliding down at constant velocity. That means everything's in equilibrium. So what I can say is that my friction force equals W cosine of 90 minus theta. And in that case, that means the friction force is going to equal 20 times 9.8 times the cosine of 70 degrees. Sorry, not 70, 73 degrees. So that gives me the friction force, and I'll actually get that number as 57.3 newtons. Now let's get the normal force. I know the normal force balances the y component of weight, and so I'm going to end up getting that the normal force is 20 times 9.8 times the sine of 73 degrees. And when I do that, I'm going to end up getting my normal force is 187.4 newtons. Now, what I can do is I can use friction equals mu n now as 57.3 equals mu times 187.4. And when I solve for mu, what I actually end up getting is 0.31. Again, dimensionless. Now, what do we do with this? Well, we just did part A, and it says if the incline is covered in ice so that friction is negligible, what would the acceleration of the block be? Well, if we have no friction, then that means the only force we have is W cosine of 90 minus theta is going to make the block accelerate. So let's get some numbers from the next page. And we know that if we calculate W cosine of 90 minus theta, we're going to end up getting 57.3. And that's going to equal m times a, which is going to be 20 times a. So when we solve for a, we're going to actually end up getting 2.9 meters per second squared. Excellent. Now, if we cut the block in half, we want to know what happened to the acceleration. And the answer is that in this case, the acceleration would in fact remain unchanged. And I'll prove this using letters. See, I know that it's mg cosine 90 minus theta equals ma, so the m's actually cancel out. So the acceleration ends up being g cosine 90 minus theta. So that's it for this particular part of the review, and we will keep on keeping on.